glory for your creation. May we learn, understand, and be able to share in a way that is helpful to us and to others to glorify you and your creation. In Jesus' name we pray. So, well, a couple things. I have a bunch of handouts there. The one handout is the PowerPoint coming up a little bit. A single page, there's two single pages. The single page has all the resources we're going to go through. You might not get through all those. Another page is an article that I read in what's called the Physics Teacher Professional Magazine from about, I don't know, 13 years ago. It's a national magazine that comes to basically all the physics teachers in the United States. Well, not all. Anybody who subscribes to the physics teacher, because I'm a physics teacher, as a professional. So basically a professional teacher's magazine. It's somewhat international as well. And all this secular stuff, once again, is slanted towards naturalistic evolution. So there was a phrase in there that I underlined and starred, and then I wrote an editorial, and they published my editorial like the next month. I was a little surprised. My response to their editorials on the back side. So that was 13 years ago already, and I've been dabbling with this for years. Once again, it's my hobby. Other things are, I've put, you can see I've put some work into this, actually quite a bit of work into this. My wife has helped me quite a bit as well. She's responsible for the tennis balls and many other things here, helping me get set up. So I appreciate that. Although I drilled a hole, she did all the coloring of the tennis balls, and they came out pretty good. But that's a lot of hole drilling, and I drilled one hole in my hand, but that's so thanks for coming back. I know you braved the snowstorm here. Other things is, so if you know of another group somewhere that might benefit from this, I'm willing to do this someplace else at some point. If you have another place or church, I'm going to do it at my school in my AP physics class. I'm going to redo this whole thing, and I'm going to save all the materials. This is all new stuff. It's not stuff that I had on hand. I've been working on this for months, if not, well, quite a while. Let's put it that way. So interestingly enough, if you get the New York Times this morning, front page. There's an article about genetic engineering and this Chinese doctor who's manipulating genes in embryos and the ethics of that. It's actually on my very last slide, which we probably won't get to today. It's on the very, very last page. Last thing is called CRISPR, where they're actually modifying things like trying to get rid of, say, Down syndrome, or make your kid have blue hair, not blue hair. They can get blue hair by dying, blue eyes, or whatever you want for your kid. But genetic engineering is a big ethical issue with that now. Because now the technology has gone so far that they can do this kind of stuff. And once again, because the technology is going as far, it's also, I think, helping us, or myself, I should say, or whoever's on the same page with me with the young earth creationism, because it's showing what's going on down there, and it's basically against all the long ages kind of stuff, and it's really favoring the young earth creationism, as I'll kind of go through with this. So the new technology has been really emboldening me and a lot of people to share this information, and you won't, once again, get this information in a lot of places. In fact, you'll never get in the public sphere this kind of information I'm sharing right here. You got to go to these websites that I have listed right there. Around my neck, what is this? Well, it's a bunch of beads. So it's supposed to represent an amino acid, but amino acids don't come like this. Okay, the DNA, each three of these pieces in the DNA is called a codon. They code for one of these pieces, one piece in this bead, which is called an amino acid. There's like 20 or 21 or 22 amino acids, depending on how you count. Okay, 3 of those code for one of these. All right, then the next 3 code for the next one, and there's like 21 of them. Okay, and then part of the machinery of the cell. Okay, the other proteins are working on this. They assemble this chain of amino acids. And this one's 170, but the shortest one in the human body is 150 amino acids long. All right? So that would be like 450 of those base pairs right there. All right? And then this has to be folded up properly. And I can't do it without breaking this thing. But it has to be folded up properly to make just one protein. And this is a simple protein. This is a simple protein that are basic for function and structure in your body. There's some that are hundreds of thousands of amino acids long that are coded by your DNA. So that's what this is supposed to illustrate is a protein strand made up of a bunch of amino acids that are coded by your DNA. Once again, quick recap. I'm going to go through this kind of fast. So the goals, to marvel at the creation, emphasize that the Bible and science, scientific study, are consistent, inspire questions. You can get your questions answered. I'm not going to have much time for questions today, but on those websites, providing the resources and communicating the importance of sharing this with other people, because I think this is an important issue, especially in today's age. Especially like when you start hearing this stuff about CRISPR and how they're going to genetically engineer your DNA to come up with the genetic babies that you want. It's very, very, very troubling right now if they start going in that direction, ethically. So the 3 viewpoints, I had these last week. One that I want to point out, the theistic evolution. In some ways, I kind of feel for the theistic evolutionists. Actually, that's the biggest group of people, actually. Most Christians are in that middle group. But in some ways, the ones that are serious about it, the scientists that are really, full force into this, there's a couple of organizations. One's called Discovery Institute and Biologos. In many respects, they don't really want to. They want to call it intelligent design, but they don't want to say it's God, or God, especially God in the Bible, for many reasons. But once again, what happens with them is they get flack from the naturalistic evolutionists. They get flack from them, okay, for being creationists, and they get flack from us to a degree because we don't feel they're biblical enough. So they're getting flack from both directions. Of course, I guess we get flack if you're up here in category 1, we get flack from basically everybody gets flack from the other 2 groups. So anyways, but hopefully we can have a respectful conversation with people. That's kind of the idea that I want to try to emphasize, even my own life, when I have people that have different views than I have. But the intelligent design, some of these resources on here are intelligent design. They're not young earth creationism, but intelligent design is a powerful, powerful, powerful thing that I'm kind of emphasizing with the DNA that points towards a creator, okay? And once you have the creator, what's he capable of? I think he's capable of anything, okay? Theistic evolutionists, I'm not sure what they really feel the creator can or can't do, but I think he can do anything he wants to do. He can speak it into being, which is what he did, I believe, according to the Bible. So, once again, just a quick review from last week. Science to me, okay, once again, I'm not the be-all, end-all definer of all terms. I could say something wrong. I am not the author of truth. Only the Bible is. Only God is. Okay. So it's possible I could say something wrong. If you got to challenge me either here or offline or online somewhere or out of class. So this is my definition of science. Might not be everybody's definition of science. It's just a logical process of studying something and coming up with conclusions. Not the conclusion itself is not the science. Once again, evolution, for me, is going from nothing to something to life to complex life. Because a lot of people, when you say, oh, you don't believe in evolution, look at the dog breeds, look at bacterial resistance. Well, that's not evolution, that's natural selection. So a lot of times when they say, oh, evolution is so proven, look at the dog breeds, look at this, look at the Darwin's finches. Well, now, almost everybody agrees that that's just variation within already pre-programmed information that's already in the DNA. That's just variation within a kind. It's not one kind changing to another kind. So that's a quick review there. So keep asking, what's your definition of science? When you're engaging other people, what's their definition of evolution? Okay, because their thought of what evolution is going to be maybe different than yours. You got to make sure you start with, because yeah, I agree that natural selection occurs, but nothing into something and something into life and life into complex life. It's all going the other direction, not that direction. All right, so that was a recap. We constructed these strands up here. So before I gave you the instructions, what were the chances of you doing it right? None. Okay. And this is only a small piece. Okay. This is a small piece. Okay, of DNA. What about when I gave you instructions? What were the chances of getting it right?
Not much better.
Not much better. Okay. It takes instructions and design and intelligence to make it right. It doesn't all come together. Okay. That's the main point. Okay. That it takes a mind-boggling amount of creative information and a designer to make it right. And it's still probably not right. And then over time, you're going to see as we go along today, it's getting worse with time. It's not getting better. The DNA that we have in our bodies is not getting better. So there's 3 billion base pairs. Okay, we did 48 base pairs. There's 46 chromosomes. Now, your DNA in your body is not one long string wrapped up. It's in 46 chromosomes. Okay, and actually some of your DNA is in your mitochondria, which is another part of the cell, which is the powerhouse of your cell. So your DNA is split up into those like X-shaped chromosomal things, and they're wound up in special ways so they don't get too tangled. We'll talk about it as well, because they can get tangled, but there's things that are automatically detangling them as they get read by different proteins. So it's amazing what goes on to copy one of these things because well, our model would stretch almost to the moon. The moon's 240,000 miles away. So that's a picture of going to the moon. Those are cows right there, but I don't know. Hey, what if it were like the Great Wall of China? I had to put this in here because I was just at the Great Wall of China like 3 weeks ago. It was awesome. But the Great Wall of China is like, it's a bunch of pieces and not one long thing. It's a bunch of, well, it's mostly one long thing, but it's got branches. It's maybe different time periods, but it's roughly 6,000 miles long. It's probably a little longer than that. Average of 18 feet wide. It's awesome. I mean, if you ever get to go there, go there. But this is my actual picture, or my wife's picture, Judy's picture. If we made ours the same width as the Great Wall of China, it'd be 18 times wider and 18 times longer. So it'd go to the moon 18 times. So I actually got there we are. That's proving that we were at the Great Wall of China. Right. Unless that's a good Photoshop, that's oh, if you want to turn off these front lights, but okay. Okay, so. A Boeing 747, which you may or may not want to get on right now, okay, the MAX ones anyways, okay, has 6 million parts. Now the DNA has actually 12 billion parts, okay, when you add up 3 billion nucleotides on one side, 3 on the other side, plus the side pieces, which we didn't even really talk about yet, the side pieces, there's also all these side molecules, okay, it's 12 billion pieces. A Boeing 747 is 6 million pieces. That's 1,000 times less. Okay? So the DNA has over 1,000 times more pieces to it. And most of the pieces of a Boeing, I looked this up, half of them are fasteners, like bolts and nuts and stuff like that. Okay? It's a pretty complicated machine. Okay? Did that come together by a tornado going through a junkyard? No. Somebody designed that. Okay? And it's way less complicated than DNA. All right? In some respects. In other respects, you've got different kind of parts because the DNA is all one sort of the same structure, but still way too complicated to come together. So, in your body, okay, you're making over 500,000 new cells per second. Over 500,000 new cells per second. Okay, and they all have this DNA in them that's been copied. All right? Think about that. Most of the time accurately, but not always accurately. That's mind-boggling. Now, it takes several hours to make the copy, but it's going on because your body has basically 40 trillion cells. Okay? Your skin, every month is new skin. So who you are a month ago was not the same skin. So, and your skin is your biggest organ, right? So whatever you see right now is different than what it was a month ago. Okay? All right? You're a whole new person. Your skin, well, everything else too in your body, except for some of the hard, non-living particles in your body. So what's possible? Okay, this is how I ended last week. What's possible? We're going to have rain or snow in April. Okay, that's also possible. I should have put on your snow in April, and then like a foot of snow and 3 feet of snow and 3 miles of snow. Okay. So it's improbable we'll have 10 feet of rain or 10 feet of snow, and it's impossible. There are things that are impossible. Things that are probability impossible, not possible. There's no way this could form by itself. No way. This DNA. So organisms do adapt. Okay. They do have good mutations, but if you do the research, good mutations are rare, if at all. Mutations, almost by definition, are bad. They're like computer programs. Like if you have a computer program, you ever have your computer go bad? Okay? Like if you change a few of the instructions inside your computer, is it likely to make your computer a better computer or a worse computer? It's going to crash. Okay? It makes things worse. It doesn't make things better. Okay? Well, now again, improbable. Good mutation, add information. There are no studies that have ever shown that you've added good information to our DNA and to the function of a living person or cell or anything. They're basically bad. Okay? We'll go through that in a few minutes here. But impossible, these 3 billion base pairs of organized information, it had to be a designer. Okay, so what you're going to do is now you're going to make the side molecules for the base. And how many molecules are there in the cross pieces? There's 4. Anybody remember any of the names of those 4 pieces? The red, the pink, and the around here. And it's short, ATCG, short for that. Okay, so I'm going to not make you, because you're, once again, the chances of you putting it together correctly without any chemistry background. So you're going to try to make this, and there's extra pieces.
Here, guys.
Tell me what you need. We'll figure it out last week.
I think the holes are too small.
See if you can make this using.
We actually got
Blacks are
Here's
carbon.
the, you gotta, oh my hand. So maybe you gotta do like color. Yeah. Yellow, where's the black one? Black, yeah, we'll check the color needs.
Is that a blue? Same thing. Nope.
We might give him a call. This because
What do we do? Going to the mall.
okay, it's very confusing. I believe we're going to the mall.
So I got you like the 3 black ones. Okay.
We gotta get you some. We have to fill those in and motorize
On both sides of the river.
People aren't done. Help the people who aren't done. I need help.
My classes acted.
I would make the circle part first. Make the circle part first.
So if you can't make the screen, you just zoom it in and then I just realized one thing on the side. Fry your eyes.
We need another.
If you zoom in, you're also making a magnifier of the light. So if you look at the light,
ATCGs on one side. There's also 3 billion deoxyribose, which is a sugar molecule. That's the purple ones I have on the side, which we didn't build. And then there's the green ones I have up there on the models. The green ones are phosphate, which we didn't build. So there's basically 12 billion pieces altogether. But each piece of those 12 billion is something like this. Each of the 12 billion pieces is made up of a bunch of pieces. Okay? Now, furthermore, each one of those, like say the red one, which is oxygen, has a nucleus with 8 protons, 8 neutrons, 8 electrons. Furthermore, the neutrons and protons are made up of what we call quarks, 3 of them. It goes down to so many different levels, okay? It's not just the DNA itself, it's all the pieces that make up the DNA. Like, this is incredible mastery, complex design, all right? It's more than just the DNA. It's all these pieces that make up the DNA. They're all in your body being made at 500,000 of these per second. All right, so that's mind-boggling. Mind-boggling. All right, so that's what those are supposed to be. ATCG. Some of you made adenine, guanine, cytosine, thymine. So those were the 4 that you made. I don't know which one you made, but I just made them random. So thanks to my wife for making that. It was hard to dye those walls. The blue ones didn't come out well, but I think we got the idea there. So those are the chemical formulas for those of you who are into chemistry. These are complex molecules. Okay? The molecules themselves that make up the DNA are complicated. Not only the DNA, but the molecules. Okay? So it's another level of complexity. It shows the intelligent design, masterful genius. Okay? It's like, and then the DNA itself is like computer coding. I went over that a little while ago. And if you mess it messes up the coding, it messes up your computer, it messes up your body. All right, those are different ways of showing those 4 molecules that we have interspersed around the room.
So the miracle is that we're all so normal.
Yeah, we call us normal. Okay, no, you're right. The miracle is that we work. The miracle is that we work. Yes. I think God is working all the time to keep us working, because I don't think it, even with the physical part of it, I don't think it keeps working unless God is actually working all the time making it work, personally. Yeah, that's a miracle. Good point, George. This is the deoxyribose. That's why it's called deoxyribonucleic acid. That's the sugar. It's called the sugar molecule. It's on the side. It's that purple one on the side. We didn't make this one. This one's more complex than the ones that we made. Okay? Okay, that's the purple one that's on the sides, called the backbone. That's the part that twists around. Okay? And then the, oh, that's the phosphate. It's a little bit simpler. It's a phosphate atom with 4 oxygens. That's the green one that I have, the green one on the models up here. Okay. Okay, so now the doctors and the evidence. Doctors and the evidence. Okay, so basically what we've done so far is intelligent design. To me, it's so convincing that there's a designer. Once again, the intelligent design people, that's as far as they go. They won't go any further than that. That there's something is beyond this. They don't tell us how or when he did it, but I think the Bible, for me, that's how God tells us how he did it. He did it 6,000 years ago by speaking it. That's how I believe it's done. Because that's what I take as my ultimate truth. But I think scientific study of this also supports this position. It's not an illogical position. Okay? You can't prove God this way, but there's certainly this mountain of evidence that supports this and makes a convincing argument that there is this God and he was creative 6,000 to 10,000 years ago, despite what they say. Now, so here are some of the resources. And I'm just going to go through, these are things if you want to do further research. So I'm going to go through these now and show a few video clips as we go through. This guy, John Sanford, these are all, so when I say doctors, these are all PhD people who believe in this. Most of these are young Earth creationists, based on what they see and how they see this genetic code in the DNA, among some other things. He was in plant breeding and genetics. He's at Cornell University. Okay, this is not a no-name place with a no-name guy. It says he helped develop the gene gun. I think if you actually look into this, okay, and you can just, what is a gene gun? Well, some analysis of actually the tool that helps us decode the genetic genome, the 3 billion base pairs. It looks at that and it sequences the genome. And then they paid billions of dollars to get this genome sequenced. Now they can do it much easier because actually I think he was the actual main inventor of this gene gun, a way of decoding, finding out what base pairs are coding for different genes that make your eyes blue or green or tall or short or whatever it is. This is a graph from his book. It's showing how, this is where it gets technical, so I'm not going to get too much in detail with this, but showing how our ages since Noah, our ages have tapered off. Now we live to be 100, 120 max, if that. Our declining fitness in our genome. Our DNA is getting worse, not better. So if you look at the evidence, if you look, because now we have special tools that can look at our DNA, and we look at our DNA over time compared to previous generations, the DNA we have is not as robust as the DNA our parents and grandparents had. If you follow that progression, what does that say? It says that, okay, we're getting worse, which means our DNA used to be what? Better. Okay, and now it's getting worse. What does evolution have to say about progression of things? The opposite. In other words, it has to work by getting things better, not worse. It's opposite of what evolution, okay, naturalistic evolution would show. Naturalistic evolution has to say our DNA gets better and better and better, and it combines and combines and combines, and finally becomes 3 billion base pairs long, making some unique, incredible machine. All right? But they look at actual evidence, and he goes through in his book, and it's fairly technical, and once again, I can't keep up with it all. The bottom line is, based on his statistics, you can't take everybody's, you got to evaluate this, compare it to other people, and watch the debates and stuff like that. But he projects that our DNA was very healthy, almost 100%, roughly 6,000 to 10,000 years ago. If you look at the evidence, how bad it is now versus going back to make it perfect, well, it lines up with biblical time frames. Or, the scary thing is, if you go forward, at some point we become so messed up in our DNA that we stop working completely, all right, and we go extinct. Which, once again, we haven't done, obviously, because we're still here. So, that's called genetic entropy. Entropy is the breakdown of the DNA. So he makes all this argument. This book is pretty, it's like a 300 or 200-page long book, but he's an expert in this field. Okay, he's a PhD. So the mutations are accumulating, 100 mutations per generation in our DNA, in our reproductive cells. So your kids, or I have 100 more mistakes in my DNA than my parents had, on average. They have 100 more mistakes in their DNA than their parents had. All right? So it's getting worse. So if you keep going with this, eventually it gets so bad you can't reproduce, and you are going to, going to die out. Okay. Most mutations are neutral. We have a lot more than this 100, there's the non-sex cells have more mutations than this, but the sex cells, the one that determine your sex and get passed on, there's about 100 mutations. But most mutations are neutral. Even in those 100, most of those are neutral. They don't have a positive or negative effect. But there is virtually no beneficial. There's no verified case of positive development in our DNA. It's always negative. We're going backwards. We had healthy DNA, according to his research, 6,000 years ago. Going forwards, the outlook is not good for us. I think Jesus will come back before that happens, though. That's what I believe. David Reeves, another guy, which I'm going to do on the next slide here. Quick video here. Let me see what this says. Oopsie. Gotta back this up. So this supports younger
Why should
time.
you believe in creation and not evolution? I mean, scientifically speaking. Haven't we proven that evolution is a fact? Did you know that for every generation that passes, more and more mistakes are piling up in the human genome? This means that your DNA has more mistakes than your parents' DNA, which has more mistakes than their parents' DNA, which has more mistakes than their parents, which has, well, you get the point. These mistakes are caused by mutations, which are basically copying errors when DNA is replicated. Now, thankfully for us, most of these mutations have no noticeable effect. But even if we don't notice them, they're still there, corrupting our DNA. A conservative estimate says that 100 to 300 new mutations occur in human reproductive cells per individual per generation. Now, some numbers are as high as 1,000 new mutations per individual per generation. That's a lot of mistakes. Now, most people think that natural selection will get rid of these mutations. After all, isn't that its job? Well, it's not quite that easy. You see, natural selection can only select against mutations that have a noticeable and significant effect in the moment. If the mutation is neutral, or even if it's harmful but hasn't caused death or serious harm, natural selection won't get rid of it because it can't see it. This leads to what's known as genetic entropy. This means that each generation carries all of the mutations of previous generations, plus its own new mutations. And with a high mutation rate, genetic entropy is increasing quickly. Actually, it's increasing so fast, there is no way humans have been on the planet for millions of years like evolution suggests. Our genetic code would be so burdened with mutations, we'd be such a mess that we'd be extinct. Our genetic code doesn't look like it's been mutating for even tens of thousands of years. Instead, it looks like it was incredibly well designed and has only been subject to the degrading influence of mutations for a short time. Now, what does this imply? It certainly fits with the biblical historical accounts that God created mankind about 6,000 years ago with a perfect genome. It wasn't until after sin entered the world that mutations began to corrupt our DNA, and there hasn't been enough time since to completely destroy our genome. Just one more scientific reason that you shouldn't believe in human evolution. It takes a lot of faith. I'm David Reeves. Truly, the heavens declare the glory of God.
Okay. So a little summary on David Reeves. He's got a lot of videos. If you go to his website, I forget the name of his website, it's listed there somewhere. But he did a couple of videos with this guy called Joe DeWeese, a doctor. And I have the videos. I'm not going to show all these. But Reeves is an author, speaker. You can see he's kind of a handsome guy. He's well-spoken. He's very articulate. So he's a very good spokesman for the creation movement. creationministries.com. He has his TV show. He has a lot of these short video clips, 3-4 minutes, like the one you just saw there. But Joe DeWeese, this guy, Dr. Joe DeWeese, he grew up in Illinois, down by St. Louis. But he has a PhD in biochemistry from Vanderbilt. Okay, he's a professor of pharmacology at Lipscomb University. I forget where that's at. But these videos, and I'm not going to show you the videos, but they're the ones that kind of show you how DNA can get tangled up and how you have proteins that untangle it. And one of the demonstrations that they use is a rope demonstration. So here's a long rope. You know, your DNA, if you put it all together, it's long and it can get tangled. Okay, it's a long, thin strand. All right, so we're going to take this rope, and hopefully the rope is not not twisted or not knotted up right now. But if Carl can maybe try to find the end. Uh-oh, there should be two pieces there. So we need to double up. Okay, hopefully. All right, luckily this rope is not knotted up right now. But that's okay. We're going to twist it. We're going to twist it because just hold it like that, Carl. Okay. Am I going the right way? Okay. So I'm going to twist this up. Okay, because this would represent a long DNA strand. So all you got to do is hold it, Carl. Thanks, Carl. So this represents a long DNA strand. So their videos, one of his videos, they have this protein, topoisomerase 2. Okay. What happens is when you have your DNA in your chromosomes, there has to be things go in there that read these codes and then make the things that's coded in the DNA. And it doesn't. What it does is it goes in there, and if we can have Vi stand up and just take two strands and pull it apart, or Judy, somebody just take two strands and pull it apart. So what happens is it pulls it apart, okay, and it has readers that go in there and read the code for the proteins that are in that part. Okay, and a lot of times when it pulls it apart, it makes knots in other parts of the strand, because when things are wound up like this and you pull it apart, other things get knotted up. And then there's special. This guy studies the proteins that untangle this if it gets tangled up. Enough said on that. But so that's how the protein. That's how the DNA is read. It's unzipped and then it zips back up and then it's copied like that. So the videos are fun to watch. I'm just not going to show them to you right now, but so that was the idea there with the rope. Okay. Yeah, those are you can't really see them too well. I don't have them on your sheet there, but you can Google that guy, creationministry.com. You can go and get these. I have all three videos. I watched all three of them. It shows you how they untangle and tangle the different proteins and how it makes the different proteins and how it reads the DNA and stuff like that. It's quite interesting, and it's, once again, very complex. Here's one. It was a movie that came out last year. Dr. Del Tech. Once again, these are all doctors. They have PhDs, so they at least are smart in one area. Doesn't mean they're smart in other areas, but only smart in one thing, whatever they studied. This guy was an engineer, worked for NORAD, which is a defense initiative for the United States government. He has worked for Focus on the Family. You might be familiar with them. The Truth Project. Okay, he hosted his Genesis History. It's a long movie with a bunch of associated movies. I watched the movie. A lot of you maybe haven't seen the movie, but it's a 2017 film. It has basically the movie is Genesis History, and of course it's begging the answer. Well, yes, according to all the people that he interviews, because this is a creation-friendly video with PhD after PhD after PhD after PhD who have studied these complex issues of genetics and the genome and things like that. So here I just have a list. I'm just going through this real fast. So these are just some of the doctors. You can Google these guys. Here's one. I just want to show you one of the videos. This is one of the videos. Again, the point is, there's a bunch of smart people.
Is used.
Okay, so let me back this up.
Genetics. What are kind of the things that we see now that we didn't see 50 years ago?
Well, 50 years ago they had the simple idea that you have a gene and a gene makes a protein. That's been blown out of the water. We now know that genes are involved in making dozens, if not hundreds of proteins, and different pieces of genes are used in different proteins at different times in the cell cycle, different times in life, under different conditions, in different cells. Most of your cells in your body, they produce similar proteins than other cells, but they're different. So your brain cells actually produce different versions of proteins than your liver cells produce.
So how's that possible? I mean, how do they do that?
It's dynamic programming. You have a gene, and this piece is used over here or over there or over there. And there's little teeny programs inside the DNA that control when and where and how to use that piece. But just recently I read a paper about actually shifting of the information in the genes. So if you start at letter number 1, you can read out this information. If you start at letter number 2, you get a totally different information. How on earth did that evolve like that? I mean, if you think of, if you read a story, maybe you're reading a story talking about some swashbuckling pirate, but if you start the second letter, it's a chocolate chip cookie recipe. We can't write that. There's no way we could intelligently program multiple levels of information into the same story. And it's what we see in life. And if we can't do it intelligently, it's not going to happen randomly.
We're talking about something that is beyond imagination in terms of the complexity, even from the standpoint of the kind of things we've done with software, and we've done some amazing things with software. But that appears to be is not even close to what you're talking about.
I like to say that the genome is four-dimensional. In software, we write in lines of code.
Correct.
Well, in mathematics, we learn a line is a one-dimensional object. It just has a length. So you can actually take a computer program and just write from left to right for millions of characters. Now, on our screens, we put carriage returns in there so we can read it. But the computer doesn't know that. It ignores the carriage returns. It's just a line. Well, DNA is a line. So in the naive concept of DNA, we had a line that had information in it. But it's not simple like that. Because this piece of DNA makes a little protein that comes over here and sticks on this piece of DNA over here, which turns on or turns off a gene.
Oh my goodness, it's like self-modifying code.
Oh, it's worse than that. Because this piece of DNA over here makes just an RNA that goes over here and interferes with this gene's RNA. They stick together, they interfere, they conflict with one another, they turn things on, they turn things off. And if you want to draw that out, you need a sheet of paper, a very big sheet of paper. You have to write all the letters of DNA out on all 3 billion of them. It would take, I calculated, about 850 Bibles as one human genome. And then you have to draw lines or arrows from one part to another part, because this part turns this part off, this part interferes with this part enhances this. It's this huge two-dimensional interaction network. That's why you have a two-dimensional genome.
So it sounds like, let me stop you for a second, because this is really amazing to think about this, because
Okay, that's not even halfway through. I'm gonna cut that short, but you can look that one up. They also get into the idea, and I'll put it in a future video because I'm gonna run short here. But this, one of the other things, and I didn't put it on the worksheet. I'm kind of mad I didn't. But this idea that we're 98% similar to chimpanzees, which they get into all the analysis of that. It's not. It's more like 80%, and that's a huge issue for evolutionists because there's not enough time in their frame to get 80% difference between our genome. They kind of cook the books, from my perspective, to get this 98% similarity with chimpanzees and their genome compared to ours. But you have to do some more research on that yourself, and don't take my word for it. We're not 98% similar to chimpanzees. We are not. It's at most 80%. But face it, we have very similar body features than chimpanzees, so I guess a lot of the coding would be the same, but it's not 98%, and that's why evolutionists they want to stick with the 98% because they can't let the 80% be there because they don't have enough time to get an 80% difference in their worldview. So he goes through that as well. This one this came out like last month. Okay, this is by Michael Behe. He's an intelligent design guy. He subscribes to all the old age stuff, so he believes the world is 14.5 billion years old. So I'm not sure what he believes as far as how God entered and put the information in the DNA, but he's a theistic evolutionist. He believes in evolution, but also that God somehow works through evolution. So, but his book is very intriguing, and once again, it just goes through a lot of the things we just were arguing about, how this is intelligently designed. And the fact that the premise of the book is basically that Darwinism is evolution. Well, the scientific evidence now is that things devolve, not evolve. Just like we've been talking about, our DNA is devolving. It's getting worse. We see that. Scientifically, we see it getting worse. We don't see it getting better. We got these mutations. And he has some readable stuff and some technical stuff, but that's a brand new book. Just came out, like I say, last month. This guy, PhD in biochemistry from the University of Pennsylvania. I watched a video, he was one that, and you'll see this on the next slide too, but he was interviewing with a guy, which I'll have referenced here. But he basically said he didn't really come out with all his information until after he got tenure. Because what? Because you get blackballed if you get a whiff of any kind of thing that's intelligent design or creationism. You lose your job basically. So he came out with a lot of this information after he got tenure. Lehigh University. So he's a smart guy, but you know he doesn't want to do he doesn't want to do the creation thing. So he won't talk about God or the Bible. But he has a lot of good stuff. Okay, I like his stuff, but it just doesn't go one step further than I'd like him to go. Once again, he works at this Discovery Institute. That's that's the intelligent design, but not young Earth stuff. So God, the information devolves, genetic mutations break, they don't create. He also wrote a book called Darwin's Black Box, 2006. This is what Wikipedia has to say about him. Advocate of pseudoscientific principle of intelligent design. It says that about all these guys, so it kind of slams them on Wikipedia. Every guy who is in their Discovery Institute, even though they subscribe to the old age stuff, this is what Wikipedia always starts off with: pseudoscience of intelligent design. So, I don't know. Here's what his own university says about him. While we respect Professor B's right to express his views, they are his alone and are in no way endorsed by the department. It is our collective position that intelligent design has no basis in science, has not been tested experimentally, and should not be regarded as scientific. That's what his own university says about him. He's got tenure, so okay. So he interviews. I'm not going to show you the 1 hour. I watched the 1 hour. It's really good. 1 hour. It's not on your sheet there. This is a good one. This was a little old. Ben Stein. This is the one that talks about how professors or anybody in the academic world, if they give any kind of hint that they're leaning towards this direction, boom, the door slams, lose your funding, all that kind of stuff. There's a wall between naturalistic evolution and academic freedom to express your ideas. He goes through all that in his video on how some professors have lost their jobs and didn't have tenure and so forth. So if you acknowledge intelligent design or have any kind of favorable viewpoint towards it even, okay, you have trouble getting tenure. If you're a scientist or journalist, you have trouble getting published. You might lose your career, your funding, your advancement. Now, this is a little controversial. It's in the video, though. Okay, he basically makes the point that Darwinism now leads to worldviews like Hitler had, like we're survival of the fittest. You have to watch the video. Okay, I'm not making this point right now, but I see where he's going with it. That Hitler was at least driven by Darwin, like survival of the fittest. Okay, I want the pure breed. All right, and that was a big thing in his worldview, is pure breeds and get rid of the undesirables, that kind of stuff. So Ben Stein is Jewish, by the way. He's not Christian. All right, so that was a big thing for him. Watch the video. It's a good one to watch. I have the video, but you can get it. This is a quote from Darwin. It's a quote from Darwin in his book, or in the video. With savages, the weak in body or mind are soon eliminated. We civilized men, on the other hand, this is from Darwin's Descent of Man. We do our utmost to check the process of elimination. We build asylums for the imbecile, the maimed, and the sick. Thus, the weak members of civilized societies propagate their kind. No one has attended to the breeding of domestic animals will doubt that this must be highly injurious to the race of man. Hardly anyone is so ignorant as to allow his worst animals to breed. Okay, it's the guy we want to respect. I don't know. A little scary. Junk DNA. Okay, I'm just going to go through real fast because we're getting short on time. Junk DNA. You can watch the videos, and a lot of it's in his Genesis history videos as well. They used to say there's a bunch of junk DNA. Okay, because really only 1 to 2% of our DNA actually codes for proteins. But hey, how about this? What if I take away some of your DNA? Let's see how you function if we take some of it away from all your cells. Okay. Yeah, there's junk DNA. They used to say there was these junk things in your body. Well, this is the credentials for this guy, for Dr. Charles Jackson. We used to have these vestigial organs like appendix. Yeah, we don't need it to live right now, but there was a function for it. Okay, tonsils. There's a function for all these organs that we found. At one time there was 180 that they thought, we don't need any of these organs. They were just left over from evolution. Well, they have a function, whether it was while you were developing in the womb or at some point in your life, they were important to you. So this is on your handout. Let me just go fast. It's got a minute or two. Dr. Georgia Purdom, PhD molecular genetics at the Ohio State University. Researcher, writer, speaker, wonder of the cell. Okay, I have one more video, but I don't think anybody will show it. But it's a fun one. If you want to go to that one, you look up veritasium, and it just shows you like how the DNA is read and how it makes copies and what's all going on. It's an incredible machinery in your cells that's reading your DNA. Every piece of your cell is complicated. Even the cell wall is complicated. that has contained all the pieces, and there's like 20, 30, 40 pieces of things in your, besides the DNA. Besides the DNA. This is a good one, replacing Darwin. This guy, Harvard Medical School, okay, so he had pretty good training. Did adult stem cell research. That guy's a young earth creationist. He works for the Institute for Creation Research. This guy's an intelligent designer, doesn't believe in the young ages, but he's very prominent. Cambridge University. Once again, if you go to Wikipedia, it says, oh, he's in a pseudoscience. He's a pseudoscience guy. Even though he's very smart, he's got some really intelligent input in his book. It's very highly researched. He's at the Discovery Institute. And then this guy, that guy, once again, I watched the interview with him and Dr. Ben Shapiro, I don't know if you like him or not, but it's a 1-hour interview with Shapiro, it's not on there. So that's on your table. All the related things, they go through all these other things that they try to rescue because they now know there's a lot of, in fact, Behe, the guy at the Discovery Institute will say, he said, off the record, about 1/3 of the actual professional biologists now, they don't believe in Darwinistic evolution. Okay, some of them have gone to this multiverse thing that there's so many I think it's what's called a rescuing device. Like, oh, we can't figure it out, so you know what? It couldn't have happened here. So there must be millions and millions of infinite universes, and somewhere life evolved. And there's this thing called panspermia. And Francis Crick, the guy who discovered the double helix, Crick and Watson, okay, he came up with this idea of panspermia that, you know what, life could not have formed here. So you know what really happened? It formed someplace else where it was favorable, and they sent seeds here to seed the life here. I mean, they believe in this stuff. Okay? They believe that it came about someplace else and then was transferred here by some other alien kind of form. It's quite bizarre as far as I'm concerned. Haldane's dilemma, not enough time. There's only an 80% match between us and chimps, and not enough time. CRISPR, I talked about that at the beginning of class today, how they're starting to play around with our genome to produce, genetic engineering. Watch out. All right, that's it. So thank you for your time. Let's pray. Heavenly Father, we thank you for the fact that we are fearfully and wonderfully made. We know that full well. May we praise and glorify you and share the good news with others. This is a season of celebration and triumphal entry into Jerusalem this Palm Sunday, and then focus on your death and resurrection for our sins. You paid the price. May we appreciate that and look forward to our final resting place with you in glorious everlasting life. In Jesus' name we pray. Amen.
Can I have your attention just for a moment?